Hello. These are two specimens of FAB NZS3 locks, and these locks are quite interesting, but unfortunately they can't be gutted without causing irreparable damage to the lock. Here's the version used for secondary locks, and here's another one that can be used for automobiles, and as you can see I opened it already, so let's see what's inside. This lock in its normal configuration has this brass collar crimped around the lock body, so to open it up it has to be taken off, and when that is done the back plate of the lock can be taken out. This back plate has a crucial role in the working of the lock, as there are three dimples into which these three pins are sitting in, and when an incorrect key is put in, so when the incorrect key is inserted into the lock, these pins will not be able to enter into the core, and the lock will not rotate. As you can see it, or hopefully you can see, the pin moves only a little bit, but not enough to really clear the hole and allow the core to rotate. When the correct key is inserted, then these pins can fully retract into the core and allow the core to rotate. There's one interesting thing also on the key and the keyway. To ensure that the key is inserted and can be extracted from the lock only in the correct position, the key has two protrusions on two of its blades, and here hopefully you can see this part of the lock housing is smaller, so when the key is inserted these protrusions hide behind the smaller part, and when the lock is turned 120 and 240 degrees, these protrusions will not allow extraction of the key. So you really have to turn full 360 degrees to be able to take the key out. Now that's the back plate. Now let's take a look at the core itself. The log housing is not all that interesting. You just see the shape of the keyway, which really allows the key to enter, and then when it's turned it cannot be taken out. Now these, as you saw already, these 3 pins can be taken out. And here you can see the front part of the lock. You can see the 3 metal bars that when correct key is entered, they can move forward and allow the core to rotate. Hopefully I will be able to show you. Sorry. Now you can see, hopefully, that the metal bar can go up and down. Now, as you can see, the core has a brass sleeve. This sleeve has a cutout here, so the lock can be pinned, or the core can be pinned using it. And the sleeve is crimped to the core, and I used a Dremel to cause as little damage as possible. And this allows me to pry this crimped part, and let's hope so, and really take the sleeve off. Now it causes a bit of a problem for gutting the lock, because the chambers go up to this height, so when turning the sleeve, a spring can enter there and can be mangled. So I will use a bit unconventional technique to clear the first row. Okay, now let's hope the spring won't fly too far. Okay, so one is down and 2 stayed where they belong. Oh, try to look for it later. Now, also, as you can see, the keyway has slight asymmetry. One of the, let's say, legs is shorter. I will use that as a guide to keep track which pin is which. So let's go clockwise. There's the second and third pin. Okay, now I will use the intended technique of gutting or reassembling the lock using the window. Okay, now the sleeve is free. Yeah, we have the the right chamber. So another pin. Okay, so that's the second row. 2 more to go. Come on. Okay. Pins flying everywhere. Okay, and the last row. Come on. It seems that one spring is slightly mangled. And the last one. So here are the pins. Now, what's still missing is are those metal bars, and to remove them, this front of the lock has to be pried off, which reveals another interesting thing. We'll try to use better tool. Let's hope there will be no bloodshed. Okay, so there's the first part. Then there seems to be steel insert. It's probably anti-drill. And then the last part again seems to be normal iron, and now these 3 metal bars can be taken out. They are spring-loaded, and they look like this. Now the core is completely empty. And here's the 3rd bar. And it's spring. Or maybe I'll put them here. Well, the way it works is following. I'll try to zoom in a bit so you can see detail of the pins. As you can see, each pin has one part that's really thin. When this thin part enters the bar in such a way, this cutout can get there, this bar can move. So to allow the core to the lock to open, all the pins have to align in such a way that their thin parts are fully inside this metal bar. Then the bar can move, and these pins are allowed to enter the core, and the core can rotate. What can be seen in here is also that there really are 3 different types of cuts. Here's one, there's another, and here's the 3rd type. All the rest are the same as one of these 3. Sorry. What's also interesting that this pin has something that reminds a bit of a spool, so it can, I guess, catch a bit on that metal bar and cause some trouble. What's also interesting is the fact that these pins, their bottom is hollow, so the spring is not all that compressed as one could think looking at this pin. And what's also interesting is the tip of the pin, and it causes a very interesting effect with the keyway shape. If the pick is not really centered on this tip, it can, or it seems that it pinches between the core side and the pin itself, and that pin can't be moved in this way, so you really have to be careful to have the pick centered on the pin. And yeah, I guess that's probably pretty much it as far as the FAB NZS3 goes. If you have any questions, just let me know. I'll be happy to answer them. Plus, I'm going to share the photos with guys from LockWiki, so it should be possible to look up the insides of this lock. Thanks for watching. Bye.